Hello, everybody. Thanks for waiting. Thanks for being here. Thanks, Envio, for the great presentation, and thanks for your question, because I will try to answer this question as well during my presentation. I'm Tomek. I'm co-founder and CTO of TokenFlow, and I'm going to propose you a slightly different approach to on-chain data analytics that is based mostly on the storage information. Okay, it works. Okay. At TokenFlow, we provide data. We provide data for complex use cases that require more data, more detailed data that you can get from events and calls. And what we do, we also try to be fully multi-chain, which means that we aggregate data from multiple chains into a single database. So all the analytics that you do, you can actually do across multiple chains at the same time. And I would like to focus mostly on our approach to analyzing data using the most important, the ultimate source of truth, which is the blockchain storage. As you know very well, every blockchain is actually about the storage. This decentralized ledger, it means that we have some data that we store, and it's changed in time by well-defined actions, like transactions. But actually what matters is what's stored in blockchain. How much tokens I have, what rights I have, what identity I have. Everything is written in the blockchain storage. And actions, like transactions, they change the storage. And actions, they emit events. Some of actions emit events, not all of them, and only in a way that was designed by developers. Because events are defined by developers in smart contracts, so you get events when it was designed by developer, and they contain the information that was provided by the contract developer. And events are very popular. Like the most of the data analytics today is based on events, and events are great. They're very simple to use, easy to use. They are well known, and if you look at the most of the dashboards, analytics, everything is about events today. But sometimes events are not enough, and sometimes events are not good. I will even say that events are bad. I will try to give you a little bit more context for this. As you know very well, events cost gas. To emit event, you have to pay for it. And today, this cost becomes important, and more projects, they started to think how to reduce this cost and how to stop emitting event or limit the number of events that's emitted by the contract. Even today, we talked to one of the projects that's building the DEX that is by design eventless. It will not emit any events. And probably some of you are also familiar with the concept of shadow events. This is the nice concept introduced like a year ago, which is approach that is based on adding some new events to existing contracts in parallel implementation of the blockchain. So you take existing contract, you modify this contract, you run this in parallel environment, and you can emit your own events. Whatever you want, you can include in this new smart contract. And this is the trend that you can see on the market, that people are looking for a way to avoid costs that is related with emitting events today. And this is one problem. One problem you are going to see less and less events going forward in the new contracts, new implementations. Another important problem is the fact that they are developer-defined. So you get in the event what developer wanted to show you. And you have to trust developer, or you need to deeply understand the whole contract to be fully sure that everything that you get in the event is actually complete, it's true, because it's something that's developer-generated. Event is not the contract storage. Event is just some representation of what happens in the action provided by developer. Another problem is, even if developer is fully trustful, all events are great, still sometimes you may find a need to change existing event, to add some additional information to existing event, or to add new events to smart contract. And you cannot do it, right? You cannot do it today, because events are implemented in smart contracts, so you cannot change it. So our maybe bold argument is that events are actually completely redundant and completely unnecessary, because everything that you get in events, you can get from contract storage, which is not easy, but it's possible. Because the storage is the ultimate source of the truth. Everything that's important is in the storage. And if you imagine, if you have access to every single change in storage history, you can get exactly the same information that you get from events and much, much more. But working with storage is very hard. This is the reason why so many people today use storage for analytics. The blockchain nodes were designed, as Envia said before me, for doing different things, not for getting the data out of the node, and getting storage data is the hardest part of it. Problem is, storage is very hard to extract from the blockchain. Storage is implemented in a way that makes it really, really hard to work with. First, the most important problem is, as you know, most of the storage is in the hashed form. If you have the hash map, so you have slot and keys, for example, you have balance of address, it actually gets hashed, and this is how it's written in the blockchain storage, and it makes it not usable at all. This is the reason why everybody says that you cannot iterate over hash maps. You cannot ask the contract for a list of holders. This is because the storage is hashed. Another problem with storage is that it's completely unstandardized. For events, for example, if you have ERC20 events, you can expect some standardization. You can expect the transfer events will be the same for every token. For for storage, there is no standardization at all, so everybody tends to implement this in custom way. Also, this is this problem of, as I called it, semantic ambiguity. It's because the same storage, the same physical storage, can be interpreted differently. It's not me. Interpreted differently by two different implementations of the same contract. Imagine if you have the diamond pattern. So you have one proxy that calls multiple implementation. They all work on the same storage, and the meaning for the storage element can be different for different implementations. Storage is huge. If you take all possible variables of all smart contracts and multiply it by every action, you get really, really huge volume of data that's actually not possible to work with easily. And also working with storage is hard. Like analyzing storage is hard, because events are very simple. We learned how to work with events, but working with storage is hard. And what we do, we try to provide a solution for this. So our approach, what we do at Token Flow, first of all, we implement the custom tracer for EVM chains, which means that we use standard node, but with custom tracer, which can be implemented in the node, and it enables us to get every single storage diff in pre-hashed form, which means that we have access to every situation when anything in blockchain storage was changed, And it's even true for the transient storage that was introduced recently with the latest hard fork. So we have every single change, and it's in pre-hashed form, so it's actually usable. Then the next step is storage decoder, that it tries to make this very complex information usable by exposing all the keys, maybe also the variable names for verified contracts. So we expose the storage in the form of storage diffs at the lowest possible level. And then we build this multi-chain data warehouse, which has what every other blockchain data warehouse has. We have all the blocks information, transactions, internal calls, events, but also this storage diffs information. On top of this, we also provide some analytical front ends for analyzing this data. But still, it doesn't solve the problems of complexity. We learned hard way during the last few years working on this, that even if we expose all this storage information, it's still hard to work with this. It's still quite cumbersome, and you need to have like very deep understanding of contract logic, and you also need a lot of SQL skills to actually build any queries on top of this storage. So today, we are trying to introduce a completely new concept that we call ecos. And ecos are artifacts that are similar to events, but they are built directly on storage information. So we take what we have, like every single change that ever happened in blockchain storage, and we, on top of this, we build additional layer of processing that simply transforms this raw information into something that looks like events. So these are the artifacts that are emitted in specific moments in processing, and these moments are unlimited. We can send echo at the beginning of the block, at the beginning of transaction, when specific storage variable is changed. We have full flexibility when we emit such echo, and we have full flexibility what we include as the content of the echo. So think about ecos like events that are generated directly from storage information. Of course, it happens in post-processing, which means that we have all the storage diffs information, and then using this data, we build some formulas to generate ecos. This is very important because this happens in database, which means you can easily build echo that you can calculate historically for the whole history without any need of reprocessing data, because all the data is there. You just apply some database operations to calculate this using the storage information. That's like the basic thing for doing anything about it. Ecos, as I said, they are directly generated from the blockchain state. We have access to every single change in blockchain memory. We have access to every action, every transaction, every call, even to existing events. We can build ecos on top of existing events. Think about transfer event. You can amend existing transfer event, and every time when transfer event is emitted, you can emit echo, which has exactly the same information, plus additional things like token name, token decimals, receiver balance after the transfer, sender balance after the transfer. You can add multiple things just to existing event. As I said, they can be generated for history just by database operations, which means it's relatively fast and cheap to generate them. And because we have access to whole history, we have full flexibility in which moment of processing we plug such echo and what we include into this. At the end of the day, you get something that looks like events. So artifacts that are precisely like hooked in time and have some dimensions, some measures that you can use for your analytics. What's very important, such approach gives us access to variables of every contract on the blockchain. So you're emitting echoes from one contract, but at the same time you can query storage of every other contract on blockchain. And if you think about it, you can also build multi-chain echoes. So you can, for example, generate swap echo that has all the information that typically are included in swap event, but you can add also on-chain price, and you can add on-chain price on other chains as well. Because if you have everything in the same database, and you can align those blockchains with time, you can extend the content of echo with information from other chains as well. So this gives us this ability of easily generating multi-contract, multi-blockchain artifacts that then you can use for your analytics exactly as you do it with events today. Some very simple examples. Think about signer change echo. We trigger this by change in the storage, in the hash map that stores the list of signers for a wallet. So we don't care how complex is the wallet smart contract, how many calls you may have, how many events are generated. We are looking exactly at one specific piece of storage, and every time when we change something in the signers list, we emit echo, which contains information about time, sender of transaction, for example, signer address, type of change, was it adding or removing the signer, cost of gas, whatever you want to add to this. You have full flexibility. Another example, I call it whale transfer. We look at the Pepe token, and we want to emit echo every time when there is a change of balance for holder that holds more than defined number of Pepe tokens. So define when you do it and what's the condition for generating such echo. And again, you can include whatever you want, like time, function that was used to change the balance, sender, recipient, amount, sender balance, post-transfer, recipient balance, post-transfer, USDC price of Pepe, on-chain price of this token, transaction sender, gas price, gas used, sky's the limit. So we believe that this approach gives us completely new abilities because we can analyze the full blockchain data and we can get this information that's very important because analyzing storage is the core of many analytics today. And what we do today, think about it. If you want to have the balance of a token in time, what people do? People take the millions of transfer events and aggregate them in time just to recreate the balance at any point in time. With this approach, you have access directly to the balance. You don't have to remember what types of operations can change balance. You know very well that for USDT and for WETH, it's not enough to take transfer events because you need to also take deposit and withdrawal events to recreate the balance. So you need to have additional knowledge about how this storage is changed. With this approach, you work directly with storage. It is much easier at the end of the day and much more reliable. And also, what's very important, you see what you want to see, not what somebody wanted to show you. So this is this approach that requires very detailed storage history in pre-hashed form, but this is what we have today. we have this information, and on top of this, we are building this additional layer that enables actually to use it for analytics in a way that's similar to well-known events. So thank you, and I'm open for questions.
Thank you, Tomek. Any questions? I think there's some right there.
Thanks, Tomek, for the talk. So my question is, do I understand correctly that you have traces, right? So like you have to run your archive node and have your custom trace. And like I'm trying to understand how do you get the context for this storage change. So like you identify moments in time when storage changes, but
Yes.
you also need this additional context to be able to construct echoes. So like, do you take it from traces? Like that's why.
Yeah, that's very important part of it, because when you execute transaction, you execute transaction as a whole. It contains inside the internal calls, right? You execute them one by one, and every internal call, it may have multiple storage changes and state changes. We distinguish storage and state. State is like the ether balance, nonce, and storage is the smart contract variables. So when you execute every call, you have the potential storage diffs that are ordered. And keeping this order and also being able to align this with the order of calls, order of events, gives you this ability that you know exactly where in this like processing stream this operation happened. So if you, for example, generate your echo on the change of the storage variable, you know which change it was, like is in the context of this specific call, this specific transaction. So this is very important to have not only access to this storage information, but also this context, as you said, which means like which transaction it was, which call it was, what is the overall state of the whole blockchain, and this is exactly in the data. So every action, and by action I mean transaction, call, emitting event, or changing storage, it's ordered, so you exactly know when it happens in this execution plan. So yeah, and you can, this is very important that you can use like all this information. You are not constrained with the scope of information that you can include in this generated artifact. Another important point here is that normally if you work with the node, you can get the storage information at the block level. So if you, for example, you have the get storage at RPC function, so you provide the address, which is hashed with keys and stuff, so you need to know keys to actually do it, and you provide block. And it gives you the storage at the end of the block. So you are blind to what happened inside the block. With our approach, as I said, we have every single change, so it's an enormous number of information, but you cannot hide anything. If you change something at the beginning of transaction and reverted this back at the end of transaction, normally you will not see the change in the node, because from node perspective, nothing changed in this block. We see that it was changed to something and then reverted back to the original value. And as I said, everything is ordered, so you can easily get this context for every echo. Hope it answers.
We have time for one question. Short answer, please. No worries, no worries.
Thank you, great talk. I have a lot of questions, but I don't want to bore anyone, so I'll limit myself to a really short one. Time and space. How much space all of this stuff does take, and how quickly can you answer a query? For example, I have a contract, I have a storage slot, I want to know the value of the storage slot at a given point in time.
Let's take Ethereum as an example. This is the big chain. So the whole processing, because as you mentioned, this requires like the initial processing. You cannot easily get this information. You have to reprocess every single transaction. And this reprocessing takes some time. For Ethereum, it took us around a month to process the whole history. But we do it only once. Like if we do it once and we do it well, we never get back to this. Then we process head, which is easy because it's not so much data, and we update the database a few blocks behind the tip of the chain. The whole database for Ethereum today is around 100 terabytes, I think. And the speed of querying, of course, it depends on how much money you can throw at it. Because we store this in multiple databases and
distributed, yeah.
And for example, in Snowflake, which is one of the distribution channels, you actually can define what size of warehouse, the computing power you throw on this query. So if you want to pay small money, it will take longer. If you pay big money, it will take it will be faster. But with reasonable size of the warehouse, you get answers in seconds. So this is what you actually need for your analytics. This requires some good understanding how to build the SQL queries to do it. And one of the things to provide this ecos is to do it for you. So the standard way of processing storage is kind of hidden for you, and you are seeing something that looks like events. It just includes the storage information in the events. So it's a huge data. It's lots of processing, but first it's doable. And it's in reasonable time. It's not something that you cannot use for analytics and actually working with this data. And it's live. It's for a few chains. We have it. We are adding more and more chains. And we can do it for every Geth, Aragon-based chain. We are also working on Red. So every blockchain that uses this technology can be easily processed just by adding this additional tracer.
I see, thank you.
Thank you so much, Tomek. Any other questions, you can always approach Tomek. Will
if you
be
want
around.
to talk, I'm here, and we also have booths down there, so we are open for any kind of questions. Thank you.
Thank you.